start tackling everything from disease control to vacuuming up ocean waste to delivering pizza and more. Drone technology has been used by defense organizations and tech-savvy consumers for quite some time. However, the benefits of this technology extends well beyond just these sectors. With the rising accessibility of drones, many of the most dangerous and high-paying jobs within the commercial sector are ripe for displacement of drone technology. The use cases for safe, cost-effective solution range from data collection to delivery, and as autonomy and collision avoidance technologies improve, so too will drones' ability to perform increasingly complex tasks. So yes, in today's video, we are going to discuss about drones, how to make drones. I'll be explaining you in this video, and please watch this video till the end so that you can get to know about many things. Now, the agenda of this video, you will learn a little history about it, introduction. You will overview about the parts, basic materials required. You will get to know about working principle, block diagram, how to put these parts all together. You will also get to know about resources, parts and community. I'll explain you about the block diagram and the application of drone, and then you will also get to know about the rules which you need to obey while operating a drone in Nepal. And then finally I'll show you a small video how to make a drone using scraps at your home. So let's begin. Over the last few years, we have seen a massive growth in manufacture and sales of remote control airborne vehicles known as quadcopter. Quadcopter is also known as a drone. These unnamed aerial vehicles have 4 arms and fixed pitch propellers with set in X and plus modes. In the standard format, 2 propellers will spin in a clockwise direction with the other spinning in an anti-clockwise direction, allowing to fly in a designated direction. Now, what will you need to make a drone? The tools you will need will largely depend on the type of drone you want to build. So, however, there are some key components that all drones require. So, these include motors, flight controller, propellers, connectors, gimbal, a micro SD card, electronic speed control, the drone frame, batteries, camera if you want to build your own camera drone, a mounting pad, an RC receiver. Now, these are the pictures of basic materials required. First is circuit board, DC brushless motors, electronic speed controllers, that is ESC, remote control, it looks like this, and then gigahertz transmitter and receiver, it looks like this, and then battery of 12 volt and 4500 milliampere, and then next multi-rotors. A quick history now. First one, it flew in 1923, a little better, it flew in 1956. Development on multi-rotors started early late 90s and early 20s. Increasing market growth, DJI about $1 billion value, 3D robotics. Now multi-rotors parts, they are frames, power distribution board or HEMS, electronic speed controller that is ESC, motors, then propellers, batteries, BEC and voltage regulators, flight controller, transmitter and receive. Now this multi-rotors frame configuration first. There are two possibilities when it comes to a frame for your drone. One is X or H format, has 4 or 8 motors, redundancy on with 8 but at a loss of efficiency, simplest to build and manage. Front cameras can have propellers or propeller shadows in view. DJI Phantom. Multi-rotors frame configuration in Y format has 3 or 6 motors. Redundancy on with 6 but at a loss of efficiency. More complex than X setup due to rear rotors requirement to rotate to turn. Clearer front facing view for cameras. Now multi-rotors frame configuration hexa and octo formats. Flat layout, hexa rotor has 6 or 12 motors, octo rotors has 8 or 16 motors and it's heavy lifting. And redundancy inherent to design, most flight controllers handle motor less loss well. Complexity not too bad, all motors are stationary and most FCs have 6 or 8 outputs. Cameras are mounted below main section. Now first you need to make yourself or the choice of frames, planning to build the frames. So now purpose of multi-rotor is aerial photography, park fun, endurance record flight times, how redundant should it be, and then you need to also plan about the size, micro or full size, folding frame or not, and then case available or not. You need to plan everything for that. So if you decide to build it by yourself, you will need some knowledge about it. You need to have the knowledge of the materials you are going to use. For instance, you can use metal, something light, plastic, or even wood slats, or even ice cream sticks also. So if you opt for a wooden frame, so you will need a wood board which is about 2.5 centimeter thick if you go opt for a wooden frame. Power distribution board or harness transfers power from the battery to the motors, flight controller, camera, etc. So basic PDBs, that is power distribution board, solder wires or bullet connectors to them. The have not voltage regulators or battery elimination circuits, that is BEC. Fancy PDBs starting to see them online also, you can see them, and they have 12-volt output and built-in BECs. And then integrated PDBs, they have some frames, example TBS Discovery have PDBs built in only. Now, electronic speed controllers, what are they? This is the electronic speed controller, and it is required for brushless motors. It has 3 wires, two for power connected to PDB, and a servo wire, 3 smaller wires that connect to flight controller. ESCs control the RPMs for which the motor spins. Amperage ratings check propeller and motor setup amp requirements. Now next is electronic speed controllers. This one firmwares allow for various tweaks and settings, and Simonke most performant ESCs with this pre-flashed on them are available, mostly flash able, and DJIs are logged, that is E300, E600, E800 tuned ESC motor sets, tuning setup, programming cards, and then with TX, RX tone and beep paste menu individually versus all at once, and then throttle range setup required. Now motors. For an ordinary quad drone, you will need 4 motors in total, but an octocopter requires 8 motors to fly. The recommendation is to use brushless motors. They are lighter on the battery, and unless you are an engineer, you completely understand how a motor works. So these pieces should be bought from a store. You can also get more familiar with them by reading about drone motors. So in drone motors, kV rating, higher kV meant for and most efficient with smaller and higher speed propellers, that is 2600 kV with 5 props, and lower kV meant for most efficient with larger and slower speed propellers, that is 300 kV with 20 inches props. And then propeller diameter, pitch and design play a factor in picking the motor. Pancake, larger diameter, most efficient at a slower, more powerful spin. So these are the pictures of motors. Now I've given you a small data over here of the motors. I've given you this item number MT2216KV1100, and it is of 11.1 volt, and then propellant, it is of T motor 2.7 CF, and then I've given you this amperes, watts, thrust, and then RPM efficiency, which one is highly efficient, and then operating temperature also I have given. So you can look in this also, you can opt from here also which motor do you need. And next is now propeller. These are the propellers and ABS propellers. When looking for the propellers, you must find the ones that match the frame of your drone and pay attention to materials. You would find wooden propellers, but you must make sure the ones you choose are good fit. ABS pros, inexpensive they are, and they are durable, easy to balance also. Cons, flexible, twice the weight as carbon fiber in my personal experience. And then carbon composite. Pros, they are cheaper than straight carbon fiber CF, lighter than ABS. And then cons, a middle ground between ABS and CF with middle ground on cost, performance and durability. And then carbon fiber, pros, stiff and light, most efficient, but whereas cons, expensive, a set 1cc and CWT motor, it is very expensive. Propellers, balancing, wear and tear, jello in pictures, video efficiency, cost, and cheaper props usually means more balancing required, and balance blades and this shaft hub, and then Dubro, my balancer, it's Dubro. Now next is batteries. So when purchasing the batteries for your drone, you need to consider the capacity of battery and its type. The most used batteries for this purpose are LiPo batteries, and their power differs. To have much better insight on this, we strongly suggest you to inquire about drone batteries. So these are LiPo batteries. I've given the pictures over here. So don't charge over 4.2 extreme danger, and then don't discharge or charge until batteries at room temperature after either, and don't discharge lower than minus 3.3 volt. If it is lower than 3.3 volt, don't discharge it, and this damages the battery too. And don't keep a puffy LiPo around extreme, it is very danger. And do use a fireproof LiPo bag or metal ammo can, fireproof safe, etc. Do charge with a LiPo charger. USB ones overcharge and puff your LiPos. So try to charge with LiPo charger only. Do follow the instruction on how to charge a LiPo with safe charger. And at last, do keep sand on hand. Water will not put it out. Now S rating, number of cells in the battery, 3.7 volt per cell, 4.2 fully charged, and then 4S battery outputs 16.8 volt fully charged. And then micro quads, that is Hubsan X4, Cherson CX10 have 1S or 1 cell LiPos. Larger multi-rotors have multiple 6S, 8s or even 10s batteries. So MAH rating, milliampere hours rating, is how much? 4200 milliampere hours, and capacity of, this is the capacity of battery. And then C rating, until LiPo technology improves, it is generally unsafe to charge faster than 1C or at the capacity per hour of the battery. BEC and voltage regulators. So now BEC, battery elimination circuit का power filter. So ESCs and motors create electronic noise that anything in the power circuit feels, can cause first person view feeds to be fuzzy when you start your motors. So BECs create clean power. Basic setup: battery, PDB, BEC components. Now voltage regulator, stepper, outputs a set steady voltage only, and then components usually don't have the internal voltage limiters. You can check the voltage requirements, avoid releasing the magic blue smoke that makes electronics work. And then voltage examples, they are gimbal controller board 12 volt, and then FPV cameras 5 volt to 12 volt camera specific, and video transmitter, it needs 12 volt. Flight controller का the brains. combines inputs from pitch. So this device steers the power and commands the motors at the same time. So it combines inputs from pitch, roll, yaw, horizontal and vertical accelerometers, GPS receivers, controller receivers to keep control of the aircraft, is connected to the receiver either per channel cables or via S-bus, all the channels on one cable, and then is powered by BECPF component or powered via one of the power connections from escape ESC, if that ESC has a BEC built in. So it's really FC dependent. DZI has a DZI specific component powered off of the PDB. So 3D robotics has one you plug in line with the battery and PDB. Now flight controller, simple comparison I have given. Logged expensive DZI NASA M-Lite, NASA V2 Wukong, plug and play but no tuning in this. So DZI dance required. So reliability question, fly away, grounded until logged, firmware updates. And then next is the Eagle 3 systems, has plug and play customizable OSD. And then Ordo Pilot, APM Pilot, open source, it is fully featured, it is fully configurable also, and full code accessibility. Many hardware vendors is also there in it. And now next is transmitter and receiver. So now this transmitter, of course, if you have a transmitter which is usually with you, you will also have a receiver mounted on the drone. So starting out, it's best to buy a transmitter receiver combo TX RX. There are a few TX and RX types, and they only will work with one of similar type. Follow the binding instructions included with the set. They are really simple to set up. So frequency most common is 2.4 GHz, and further range and obstacle penetration is required. Ultra high frequencies used. So channels used to list a 6-channel TX RX set. So each of the pitch, roll, yaw, throttle require a channel. That's 4 so far. All flight controllers have multiple flight modes. Another channel now up to 5. Now other components required are on-screen display OSD used to display telemetry, altitude, GPS, voltage, heading, etc. And then gimbals and gimbal controllers, FPV systems, camera VTX, Google and monitors, ground stations, VRX and TVs, dipole, and then cloverleaf, Yagi, other antenna types are also required. So aside from the mentioned part, we can also need AWZ silicon wires, a battery charger, servo lead wire cables, zip ties, the 3M command strips, and then thread locking compounds, etc. So in addition to these components, you can also embed other accessories to your drone and make it more advanced. So in other words, there are many ways to build a drone, and depending how much of it you truly want to make it a complete drone. Basic tools needed to build some small setup: Phillips and flathead screwdrivers, metric and standard Allen, soldering iron with solder, helping hands, harbor freight, and then wire cutters, strippers, heat shrink tubbing, harbor freight, and then a lighter, a heat gun for the tubbing. Now, so how do all these parts go together? Now, first you need to have know the step by step. You need to focus step by step building a drone with pieces that you can separately make them together. So I'll be explaining you. First step is frame assembly, making the frame. No matter what your drone is going to be, it must have a frame. So the first task is to make a frame. For this purpose, you can use different materials such as metal, plastic or wood. So these materials will differ based on how sturdy you intend the drone to be. So if you select wood for the frame, find a wood board that is longer than 60 cm and about 25 to 30 mm thick. Cut up this board in such a way to get two laths which are 60 cm long and 30 mm wide. And these two lengths are required to make the structure of your future quad. Crossing these two laths, you will make the X frame like this, X frame. Also, you will need a wooden seat in order to make and add a rectangular piece in the central part of this frame. Its size should be 6 into 15 centimeter and about 2 mm thick. Of course, you can use other dimensions if you like, but these will get you a pretty nice quad. To connect these parts, you will need nails and glue. In case you decide to go with metal or plastic, the dimensions are similar, but the way you connect the laths together is going to be different. Mount motors. So the escapes, the ESCs, electronic speed controllers, the motors and the propellers are among the most important elements of functional drone. So you should get these components from an authorized store to ensure quality and reliability. They must be in accordance with the size of your drone. So bear this in mind when buying them. Do not be afraid to ask for assistance for someone at the store. When looking for the motors, you should know that multi-rotor drones produce greater speed and ensure a stable flight as each rotor works with the other thrust points. So I have explained you this earlier also. So for the propellers, we suggest to buy the metal 9-inch props at very affordable price in the market. These are durable and won't bend so easily if the drone hits something during flight. So however, if you want better performance, it would be better to go for carbon props. If you want good performance, we recommend to get any of these. Now, next step is ESCs to motors. So you need to pick up some ESCs, that is electronic speed controllers. If you don't want 4 of these, can buy the 4-in-1 controller also. So now The next thing you need to do is drill the holes in the frame for the motors according to the distance between the screw holes on the motors, and then it would be good to make another hole that will allow the clip and shaft of the motor to move freely. So however, you may skip this action if the motors already came with mountings, but the motor in the appropriate place, and fix it to the frame using the screws and screwdriver. And then mount the electronic speed controllers. After mounting the motors, you will also have to mount the speed controllers, and it is recommended to connect the speed controllers on the bottom side of the frame due to several reasons which involve the functionality of the drone. So these reasons, among others, include that it will unload the upper side of the drone with other components should be added. So in order to fix the ESC very well to the frame, you need to use zip ties, and this way your ESCs are tied down and well secured while flying. Don't worry about direction of rotation. If wrong, swap any two ESC wires to reverse motor direction. Now, next step is power harness without a PDB. So this power harness without a PDB, you can fit like this. I have shown in the big picture. So here this is a receiver, and this flight control board, and this is BCs, and this is ESCs. This is 3.5 mm bullet connectors, and these are the motors, and this is again wiring harness, and this is CS connectors, and this is battery alarm. This is a battery. Now power harness with a PDB will connect like this. Next, power harness with a frame based PDBs will connect like this. This is a frame over here, and it is connected like this very easily. It is quite easy, like connecting like, and then connect ESCs to flight controller, and then controller RX to FC again, and now connect to FC software and calibrate. Now visit manufacturer site to get correct drivers, verify controller connectivity, update firmware, calibrate compass, process varies per FC, calibrate accelerometers, and calibrate controller modes, sticks, switches, and then finally set up initial flight modes. Next step, verify motor rotation. Keep propellers off. Most flight controller software will have the ability to test rotation of motors to verify that the escape ESCs are wired correctly. And then if you can't verify it via software, you will just have to test via throttling up. Step is test flight tune. Now in a safe area, let FC set its GPS location. This can take a while if it hasn't done it recently. Verify that it is ready via LED output and tones based on FC. Do not learn to fly with it in GPS mode. Use it as an aid later, not a crutch from the start, or use a test rig. Now, what is the working principle? So, quadcopter is a device with an intense mixture of electronics, mechanical, and mainly on the principle of aviation. Quadcopter has 4 motors, already explained before, so whose speed of rotation and the direction of rotation changes according to the user's desire or our desire, the one who creates their desire to move the device in particular direction, takeoff motion, landing forward motion, backward motion, right motion. The rotation of motor changes as per the transmitted signal sent the form 4-channel transmitter. The signal from microcontroller goes to ESC, which is in turn controls the speed of motor, the program for which is written in the ATM EZA 16 chip. Now motion, takeoff motion and landing motion will be smaller, causing the quadcopter beginning to fall. In order to keep the quadcopter stable, the thrust of each rotor should be increasing order for compensation. Now this is the block diagram of the drone. The layout of quadcopter. What are the applications of drone? The application of drones, they are news making, agriculture, delivery, internet, photography, videography, for the people, military. What are the advantages of drones? It has successfully struck militants of Al-Qaeda and other terrorist groups. Intelligence gathered by surveillance drones contributed to the assassination of Osama bin Laden. It helps to detect forest fires, monitor environmental data also, that is populations of animals. It can seek missing children and felons too. The disadvantages of drones. Domestic drones violate right to privacy. Some drones are lethal and not just used for surveillance. People feel paranoid and like they are being watched by the government. With drones being unnamed flying machines, less aviation jobs are needed. They are very expensive and rarity among the world. Now finally, it can be concluded from the above discussion that as with other man-made technologies, this is also not without its benefit and drawback. The need of time is to research upon its advantages rather than disadvantages. Now I am going to show you the steps how to prepare full video regarding how to prepare a drone. So let's begin. for flying a drone in Nepal. Based on research and interpretation of the laws, here are the most important rules that you should know for flying a drone in Nepal. For drones weighing more than 2 kilograms, that is 4.5 pounds, that fly 400 feet or more above ground level, prior authorization from the Department of Tourism, Ministry of Home Affairs, and the CAAN is required before operating a drone in Nepal. Drones weighing less than 2 kilograms, that is 4.5 pounds, do not require authorization from the CAAN, so long as if they are flown on a private property under 200 feet. Do not fly drones in a reckless manner. Do not fly drones higher than 120 meters, that is 394 feet. Do not fly drones further than 500 meters, 1640 feet. Drones may not be used to drop articles or animals. Do not fly drones over within 150 meters, that is 492 feet, of any congested area. Do not fly drones over within 150 meters, that is 492 feet, of an organized open-air assembly of more than 1,000 persons. Do not fly within 50 meters, 164 feet, of any vessel, vehicle or structure. Operators must maintain unaided visual sight with the drones. Airport areas must be kept clear of all drone activity. For more information on Nepal's drone laws, you can also visit CAAN website. Thank you. Hope you enjoyed this video. Don't forget to subscribe for more interesting videos in the upcoming days. Till then, have a nice time.